Thanks for listening to the Innovation Experts, a new global podcast brought to you by Farnell, Newark, and Element 14, where you can find out about the latest innovations in the world of electronics. Hello and welcome to our next interview from the Innovation Experts, a global podcast from Farnell, Newark, and Element 14. My name's Cliff Ortmeyer, and I'm the Global Head of Technical Marketing, joining you as usual from Chicago. Today we have Brad Odner, representing Tektronix and Keithley Instruments from Cleveland, Ohio. Welcome to the podcast, Brad.
Thanks, Cliff. Happy to be here.
So let's start off with you just telling us a little bit about yourself and your career. What caused you to join Tektronix and Keithley?
My background is in physics. I actually started in school using Tektronix and Keithley equipment in my electronics labs for my degree. And at a career fair, because I went to school in Cleveland, I ran into Keithley Instruments, started co-oping there, and just really fell in love with the industry. I think it's just such a fascinating industry to work in because you find out so much about basically every other industry, anything that has to do with electronics, and you get to really be on the forefront of all of those innovations happening in other industries because everybody has to test and measure their equipment before they're allowed to do anything with it. So that's really what drew me in. And so I've been working with Keithley and Tektronix ever since.
Yeah, I got to say, I think Tech was one of my first scopes. And honestly, I have one in my basement that's, it's got to be 20, 30 years old. And I just can't part with it because it's a mainstay. So I understand this is the 75th anniversary of Tektronix. So, how are you guys celebrating this?
We are very excited to have been around for 75 years. And it's actually both Tektronix and Keithley, funnily enough, are celebrating their 75th anniversary the same year. In terms of how we're celebrating, I myself have been doing actually some teardowns of our really old, even original equipment. And so I've sort of been diving into the history, and there'll be some videos if you watch our YouTube channel on some of those teardowns of our original equipment, because it's really impressive, I think, to look back on what our industry was like 75 years ago, really how far test and measurement and all other equipment has come.
That'd actually be super cool to see how an old scope varies from the past to today's scopes in terms of the equipment that's used, the types of components, and really if the measurement method has really changed.
Yeah, in some respects, it's very similar. I mean, when you look at an oscilloscope, we're still just measuring voltage and so logging that voltage over time, really fundamentally. But the method in which we do that it's been amazing. Now oscilloscopes work mostly by a single system on a chip that handles a lot of the signal processing and analysis functionality. A lot of oscilloscope technology is really just trying to get a signal from an input into this system on a chip to do a lot of that measurement. Compared to the original oscilloscopes, we're really just using tubes to amplify a signal, and it just happened to be displayed on a screen, but it wasn't really any fundamental logging going on.
In terms of the history, to me, it's very interesting going back. What are the things that Tech and Keithley have pioneered being around for this long?
So speaking of Keithley Instruments, one of the big innovations that they had pioneered were source measure units, which are a type of instrument that can source and sync power, both voltage and current. They're fairly complex instruments. They're very distinct from a power supply, but they're in some respects integrating the capabilities of a power supply and a digital multimeter. They're very fast instruments, and they're used quite a bit today in a variety of different industries. But they really started because semiconductors started to become really prominent, and mass manufacturing of semiconductors was starting to become a thing. And these manufacturers needed a way to test their semiconductors as they were being made and being printed. In particular, diodes. Diode is a fundamental semiconductor component. As they started to become mass manufactured, those manufacturers needed a way to test them. So they came to Keithley Instruments, who they were already working with for their other testing needs. And we worked with people in order to develop this brand new class of instrument, the source measure unit. It's not too often that you get to develop an entirely new class of instrument.
Yeah. I think SMUs are one of those ones that Even though I worked at a semiconductor company for 15 years, it's one of the things that I never actually used, but it seems like they're becoming more and more of a mainstay, especially with LEDs coming out, and they're not just used in the research areas and production facilities. They're actually becoming more on the bench and being more commonplace, at least from what I'm seeing.
Yeah, and you also start to see them in things like battery testing. So, there's a lot of startups out there doing IoT devices, especially right now, becoming even more common. And source measure units are great for companies that want to have one instrument that can do a lot of things, but also very complex things. As we start to talk about, the miniaturization of devices, needing a lot of capability on a very small device, sort of the same thing with test and measurement equipment. People are trying to get the most bang for their buck, so to speak, from any piece of equipment that they use so they can make the best products possible.
In general, what do you see the biggest issues being from a measurement standpoint?
One is the ability to quickly interpret data and get results for a test. The world is not slowing down at all. I don't think anyone would argue that. And so that goes for companies developing products too. There are shorter and shorter time frames. Engineers are pushed harder and harder to get results, develop faster. And that makes its way into our industry where customers and engineers don't want to be spending a lot of time setting up a test, interpreting data. If you think about historically having to use analog equipment, you have to spend at least some amount of time looking at that needle to try and get the actual measurement that you need down to the resolution that you need. Compared to today, where we see more and more engineers doing their tests completely automated. They will code up their test equipment. And so they will basically never look at the raw data. They only look at the results that are compiled for them. So that's one area, is that being able to quickly and really as fast as possible set up and get results from a test. The other side of that is the evolving standards that we see. So things like PCI Express, PCIe, and other computer standards that are just always moving forward. Even as soon as one standard is out, the next revision of a standard has already been in development for a few years. And so that is a huge pressure for companies that work with those different standards across every industry. Really, every industry has standards in trying to keep up with that evolving pace. So would be the other challenge that people have, in that it's a lot of learning. Every few years, you have to keep up to date on what the changes are that happened, what new testing capabilities you need, etc.
That's a good point about like the testing standards and things like that. Like say 5G, I've always wondered, how do you develop the equipment that's necessary to develop new standards and things like that? How do you know what to even make to help bring about the next new technology?
It is a very difficult question, and it's something we spend a lot of time on. It's actually one of the core aspects of my job. But really, across Tektronix, we have people going out, well, primarily, I guess I'll say, talking to customers, which I don't think would be a surprise to anyone, especially no one that has worked with us and actually talked to us. Is we spend a lot of time talking to customers to figure out what they need right now, but more importantly, what they're going to need in a few years. If it was easy, then we would be able to basically predict the future. And that's sort of what we're trying to do: see where all these different industries that we play in are moving within the next few years. And we need to make sure that we have products available for them. Just very recently, we joined the SOSA consortium, which is the Sensor Open Systems Architecture Consortium, which is a new standard that's developing for military and government use. And so we'll keep up on those boards, try and both guide and also learn about what those requirements are going to be, where the technology is headed in a few years. So it really is quite complex. Basically, everyone in Tektronix and Keithley is working on trying to predict the future all the time to a certain extent.
How do you guys see yourself being differentiators? What are some of the key areas that you see yourselves excelling in?
Yeah, there's a few different things to look for in comparing, and obviously it's different depending on exactly you want to look at. But one key one is just the individual capabilities of our instruments. Is something that we will often try and differentiate ourselves with. So while you might be able to meet the compliance certification for some standard, for example, you may be able to even exceed that compliance certification. And so what that can do is if a company is looking to meet some standard, sure, you can meet the standard, but if you exceed it in certain ways, then that might allow you to get an edge on your competitors. And so, what we might do with our equipment is we might try and exceed the standards needs in certain ways, whether that be the speed, the clarity, resolution of whatever test you need. Frequently with standards, we're talking about communication buses. And so, we might be looking at trying to increase the resolution to which we can measure the ones and zeros of that communication bus. We may be looking to be able to measure a little bit faster so that the capabilities there that we can then pass on the value of those enhanced capabilities to our customers is one area that we do, that we try and compete, one place to compete. Along with that capabilities, there's also the ability to integrate multiple standards, testing standards into one piece of equipment. So when you look at one of those data bus standards, you will often have separate standards for TX and RX, the transmission and receiving side of that communication bus. And so another place to compete is by offering both standards, both compliance standards, with a single piece of equipment or with fewer pieces of equipment than competitors. So that's another way that we can try and compete. Another one is with ease of use, and that's a big one because we talked earlier about one of the pressures in the test and measurement industry is being able to complete tests faster and get results faster than anybody else. So if we can make our products easier to use than our competitors, then that offers us a huge advantage because then engineers don't have to spend as much time understanding the test equipment and they can spend a lot more time understanding their design that they're working on.
Yeah, I definitely see that, especially when it comes to a touch screen. I think the two key things are, with the integration of additional capabilities and even with touch screens. I was mentioning before, looking at the 3, 4, 5, and now even the 6 series scopes, I look at those things and to me, they're beautiful. From a geek standpoint, they're just amazing. And I mean, I wish I would have had something like that, 20 years ago when I was playing on the bench. They're just amazing. So I'm guessing that the UI is a big portion of where you have to spend a lot of time, especially with that much integration.
Yeah, we're very proud of that interface on our newest series lines of scopes. I'll tell you that UI was in development for several years, completely brand new, started from scratch. When the development team started looking at making a new oscilloscope with the 5 series, which came out in 2017, I think, they really started and look at, okay, what are engineers going to need for the next years while we have this oscilloscope available as a platform? And one of the key things they looked at was ease of use. We see this trend that engineers are wanting to be able to do things faster and easier. So they looked at designing completely from scratch a brand new UI that became our current UI on our 3, 4, 5, and 6 series oscilloscopes. I have to say, even I started using one and it completely spoiled every other oscilloscope for me because it's just so intuitive to be able to do things. We'll take one of those oscilloscopes into high schools and do demonstrations occasionally or work with a high school class to teach them things about test and measurement. And it's amazing you can see high schoolers that maybe don't even have any experience using an oscilloscope being able to do analysis and just really intuitively play with signals that they're able to see there. That I think is really unique in the industry. I really don't think there's any other even oscilloscope UI that does anything like that. And so that is something, yeah, we're very proud of with all of our user interfaces and trying to make it a lot easier for people to get what they need out of our equipment.
Yeah, I think it's almost a necessity. I mean, when you're doing mixed domain analysis in a single device, I don't know how I was just amazed when those first started coming out. You've got a spectrum analyzer combined with a scope, and I'm like, holy smokes, that's amazing. So with the integration, I would imagine that having more, I guess, responsive displays and interfaces is almost a necessity when you start, bringing devices together in one platform.
Yeah, and when you start to do there, the real challenge becomes how can you make it obvious to a user what they're actually doing? That's a big challenge and something that I think we've tackled pretty well, but that does become very difficult. How can you make a part of an instrument indicative of what it's doing and also intuitive to use? Because talking about like a spectrum analyzer and an oscilloscope, you really use them in quite different ways. They have different knobs, so to speak, that you turn in order to change the results. So making that clear to users while also trying to minimize the number of things they have to memorize and interactions that they have to do is a core challenge that we address.
Yeah. I think the integration, kind of like what you were saying with the SMUs and with these types of things, to me, it seems like the next frontier in terms of what to expect from a test standpoint. What can you tell us? Nobody's listening, I'm sure, but if you can tell us secretly, what's the next generation is going to look like in terms of features, improvements, combining more devices into one, and does it make sense always to take multiple devices and put them into one unit? What are your thoughts on that?
Yeah, the sort of consolidation that we see in test and measurement equipment is really intriguing. And that, you're right, is a direction that the industry is moving. But I'll start off saying I don't think it's appropriate in every case to combine instruments all into one. But in other cases, it definitely does. So, for example, with our 4, 5, and 6 series oscilloscopes, what we have done is added some nice hardware into them, which is called a digital down converter available for every channel of those oscilloscopes. And what that allows you to do is do frequency analysis on a time domain signal. And the way we've architected it, you're actually able to do both simultaneously. So you can look at the same signal in the time domain and in the frequency domain across every channel of that oscilloscope. And so what that does is you've effectively got a oscilloscope that is now also functioning as a spectrum analyzer, as you hinted at. So that's one thing where it does make sense to be able to do that, because oftentimes you're needing to find, as an engineer, a frequency domain anomaly that is happening on a time domain signal. Or say, for example, if you're looking at a power bus on a integrated device or on a board, and you might be seeing errors in your power delivery network, your PDN. And it turns out that in looking in the time domain on that, you can't really see anything. But as it turns out, if you look in the frequency domain on that same signal, what you'll see is maybe the frequency of your switching power supply that is somehow maybe traveling over lines, getting into some line that it's not supposed to be. So from that respect, that development really grew out of what we were seeing needs for. We started to see engineers, I have this time domain signal, but I have to hook up a spectrum analyzer too. So what we did was we integrated the capability that engineers needed into the oscilloscope that they were already using. At the same time, if you were to try and integrate the functions of, say, a power supply onto an oscilloscope as we know it today, that might not be as useful. Yes, you always need a power supply, but that would come with a lot of hindrances to your test setup too. So what you start to see in some, particularly like low-cost instruments, is maybe a black box. We call it black box instruments, which is one instrument that maybe does half a dozen different things. But what you'll find is it doesn't really do any of those different capabilities particularly well. It doesn't excel in any of those different things. It just can technically behave as those instruments. So the challenge a lot of times is how can you make a instrument that excels in something and also excels in a completely different class, that importantly also offers you capabilities that you wouldn't have before. Uh, Being able to hook a spectrum analyzer up to a time domain signal can sometimes be difficult or impossible. So integrating that capability into a single oscilloscope offers you capabilities that you didn't have before. So the key thing to look for when we talk about consolidating test equipment as we go forward is really looking at what capabilities are needed on that equipment. Where are you having to combine instruments or have to use two instruments together for a same test? And that's really what we look for. So if you are good at predicting the future, like we try to be, then you might see in the future where we may combine capabilities of instruments together in order to really, once again, to ease our engineers and our customers' lives.
I think the digital sampling on the multimeter, I can see that being useful just in general applications where you just need to see whether or not, say, a rheostat or something like that, what's the waveform actually looking like? Can you see that without having to bring out a scope or something? So I can see a lot of applications where that would be useful. One of the ones that when you mentioned, in terms of the features and the capabilities, it doesn't always make sense. When I look at, the SMUs, one of the things that I'm constantly amazed by is the measurement, the precision that you can get in the measurements. Are we getting close to the point of no return, or where you can't even get the measurements that you're looking for because of the precision that's needed? What, you have any ideas on that?
Yeah, this is particularly an issue, I would say, for our Keithley product lines, because Keithley, again, has always been a company focused on precision. And really, one of our internal taglines that we use sometimes is Ohm's Law on steroids. The famous Ohm's Law, V equals IR. And at Keithley, we like to think that we take it to the extreme. And how far can you take those measurements on voltage, current, and resistance? And yeah, I mean, fundamentally, if you just look at where we are, how far we can measure, we are really reaching basically the limit of how sensitive we can be with our measurements. When we look at the Tektronix side of things and the speed, yes, we can still measure faster. We're having to develop completely new technologies, brand new architectures in order to do that. But there's not a fundamental hard limit as much as there is for voltage, current, and resistance. We have a handbook, actually, our low level measurements handbook that we've been publishing for almost 50 years now, actually, that talks about this in really the first few pages. Because you think about talking about low level measurements, one of the first things that you want to be able to ask is, okay, well, how low can I measure? Turns out there is fundamental limits to that. The universe doesn't allow us to measure certain voltages on certain resistance materials because you actually hit the uncertainty principle. There are just physical limits of our universe for how far you can measure. It's not terribly common that you run into them in everyday scenarios, but if you think about digital multimeters, you'll have your 4.5, 5.5, 6.5 digit multimeter, and that refers to the resolution of if you measure 5 volts, how sure are you that it's 5 volts? And you can go out some number of digits, 5.1, 5.123, etc., out to 6.5, 7.5 digits. The highest resolution digital multimeter you'll find really is a 8.5 digit multimeter, and those are used in calibration labs almost exclusively. And because that resolution really starts to hit on the limit, you may be able to go maybe one more digit, but functionally you need really in very intense and very specific scenarios in order to be able to get that extra digit. And so the 8.5 is practically the limit that we run into. So then the functionality then becomes, well, can we measure it maybe better under more circumstances? So how can we improve our processes and architectures inside the instrument so that maybe you can use it in more temperature ranges, or you can go longer between calibrations? Those are some of the things that we start to push for. And what you also start to see too is when we reach those hard limits is that the instrument changes start to become much more incremental. A change in resolution from a 4.5 to 5.5 digit is very obvious. You get another power of 10 resolution on your measurement. When you start to look at some of our instruments that approach those limits today, they are a lot more incremental changes, I guess. So, we do start running up against the hard limits of the universe in terms of where we can take measurement science. But also, that's the fun thing.
Yeah, I'd imagine for most cases, except for guys and the ladies over at CERN or something like that, really the machine has more capability than most of the engineers have the ability to even measure, just because of the parasitics and the probes and making sure that everything's actually, the connections are right. Because when you start getting to that granularity, it's not just the machine internally can it do the measurement, it's how are you actually acquiring that probably comes to be more of a stumbling block than the machine's capabilities, I would guess.
Oh, definitely. Test setup can be a problem and can introduce errors, not even at that fundamental level, but we see test setups cause errors all the time across basically every industry. So that is a big thing we focus on, is trying to help our customers make the best test setup that they can. And we try and provide as much guidance as we can really on how to minimize those parasitic capacitances. And a lot of times, it's very simple things like shielding your measurement setup, minimizing cable length, etc. The hard part and the fun, challenging part comes in when we come across scenarios where the test setup can't change for some reason. There's just some reason why the customer cannot change their test setup. And that's where it becomes a really interesting challenge for us, because then we have to think about how we can either improve our equipment to handle that test setup, or what else we can do, modify it somehow in order to meet those needs. Yeah, so that's always a really interesting, engaging conversations that we get some good brain power out of. That's another area that I sort of hinted at when we are talking about those fundamental limits, those incremental changes that I was talking about. A lot of them are things like, maybe we can measure 8.5 digits at a higher parasitic capacitance, so with a longer cable. Those are some of the changes that you'll start to see in those instruments, or really just that the test setup, improved test setup capabilities maybe.
Well, I got to tell you, I could go on for another hour or two. This has been awesome. I mean, I've learned a lot, and actually, I'm really looking forward to your teardown because I think that's going to be pretty interesting. So I'll be looking forward to that. But before you go, I gotta throw a couple quick fire questions. I like to do it at each round just to get to know whoever I'm interviewing a little bit better. But when you're talking about the different applications that the people are using, what's the craziest application that you've seen or heard? Either a Tech or Keithley device being used in.
I come across stories quite often. I would say for one reason or another, one that sticks in my mind is a chicken processing plant that got one of our data acquisition units to measure the temperature of their chickens as they were cooking in these huge ovens. And so that's a fun one, maybe because I just really love chicken, but that's an application that's always stuck with me. I'm like, yeah, I guess they would need to measure the temperature somehow for quality control. And well, they use our equipment for it.
That one's unique.
My favorite applications are where you get some industry that you wouldn't think of using test and measurement equipment, but they'll buy our equipment because it turns out it meets their needs. It does what they need to do.
So speaking of chicken, and I'm a big griller myself, and that's pretty much what I spend a lot of time doing on the weekends. What do you got planned for any upcoming projects or any cool weekend things you got going on?
Well, I have had this ongoing project, ongoing for longer than I'd care to mention, really, but repairing a 1953 Magnavox radio cabinet that I have from my grandparents, actually. I might work on that a little bit more this weekend, trying to repair the motor drive and also upgrade the motor drive to be able to play at different record speeds. But that's a cool piece because it's all tubes, all hand-done circuitry. There's no boards or anything. So that's a very fun project to work on.
Well, if it's got tubes, it's now considered audiophile. So congratulations, you're an audiophile. and
no comment.
Lastly, yeah. So let me ask you this one. I'm a big Marvel fan myself, but who's your favorite superhero and why?
I am also a big Marvel fan. I am tempted to say Iron Man for corporate reasons, because I think Iron Man has done a lot for get people interested in technology and science more. But realistically, I think I have to say Thor, because Taika Waititi is one of my favorite directors, and I just really love the direction he took Thor in. So as of right now, Thor is my favorite superhero.
Okay, I get you. My daughters still don't understand why I like Tony Stark. Like, Dad, he's obnoxious, he's arrogant, and I'm like, sweetie, he's got all the toys and he's a genius. So I got to
exactly
lean that way. But hey, super, really appreciate your time today and appreciate everything that you've brought to the podcast. What's the best way to reach you at?
They can find me on LinkedIn. They can always email me directly to Bradley, Bradley.Odhner, Odhner, at Keithley.com is my email address. But yeah, it's been a pleasure talking with you, Cliff.
Thanks very much. I appreciate it. So thanks for joining us on the Innovation Experts podcast. We hope you've enjoyed today's episode, and I'd like to encourage you to check out Brad Odhner as well as Tektronix and Keithley and find out more about their specialist products and services. So with that, we'll end today's cast, and thanks again.
Thank you.
We'd like to hear what you have to say about how test and measurement equipment supports innovation in your industry. So please get in touch with us at technology@farnell.com. If If you enjoyed the podcast, don't forget to subscribe on Spotify, Apple Music, or wherever you get your podcasts. All right, I'll see you all for another interview on the Innovation Experts very soon. Until then, thanks for listening.